In this video, we will expand a binomial. Now, you can use Pascal's triangle or the binomial theorem to expand a binomial. But in this video, I will show you a trick that maybe is a little bit easier to memorize, and you don't have to build all of Pascal's triangle in order to determine the expansion of the binomial. The one caveat here is that if you want just a single term, then the binomial theorem might be more applicable, but oftentimes in calculus or pre-calculus, we want the entire expansion of the binomial. So I will first look at the technique and explain that, and then we'll look at a couple examples. So at first it might seem a little weird or clunky, but don't worry, hold on. So let's imagine that we have a plus b to the nth power. So n here, for our purposes, will be a counting number, 1, 2, 3, or so on. The easiest thing to do at first is just determine what happens with a and b, and then lastly we'll look at the coefficients of each term. So a, we will start with a to the nth, and then every subsequent term, a is raised to a lower power, all the way down to the first power, and then it's no longer present. B does exactly the opposite. There is no b in the first term, but then in the second term, we have b to the first, and then b to the second, all the way down till b is raised to that nth power. So then the difficulty comes in, how do you obtain the coefficient? So this n times n minus 1 times n minus 2 over 6, why is that the coefficient of a to the n minus 3, b to the third? Well, the explanation of why that is not something that we're going to do. All we care about in this video is finding it. So to find it, we look at the previous term. So we will look at the coefficient of the previous term, and we will look at the power of a on that term. Now we will multiply those two quantities together, and then notice this is the third term. So first term, second term, third term. So we will take and multiply those two together, and then divide by which term it is. And that will give you the coefficient of the subsequent term. So let's take a look at an example. If we want to raise the quantity x plus y to the fifth power, let's first look at what happens with the variables in the term, and then we'll come back and look at the coefficients. So we'll start off with our first term. We'll have x to the fifth, and then the next term, I'm going to leave some space for the coefficient, will be x to the fourth, and then y will make its debut. Leave some space for the coefficient, and then we'll lower the power on x, raise the power on y, plus, leave some space, x squared y cubed, plus, and now leave some space. We're down to just x to the first and y to the fourth, plus, and now we finally have just y to the fifth. Let's look now at the coefficients. The coefficient of the first term is always 1 initially. And then we'll look at the subsequent term. So we need to find the coefficient of x to the fourth y. To do that, we take the power on x, which is 5, and the coefficient, which is 1, and we divide by the fact that this is the first term. So it'll be 5 times 1 divided by 1. 5 times 1 divided by 1 is 5. Now we'll look at the next term. If we want to find the coefficient of x cubed to y squared, we look at the previous term again. So this time we will look at the fact that we have the fourth power of x times 5, the coefficient of that term, and then this is now the second term. So we will have 4 times 5 divided by 2. And 4 times 5 divided by 2 is 10. Now let's move to the fourth term. If we look at the fourth term, we know that to find the coefficient of the fourth term, we need to look at the third term. So we will have the power on x times the coefficient divided by, this is now the third term. So 3 times 10 divided by 3 is 10. Now let's look at the fifth term, and to find the coefficient of the fifth term, we look at the fourth term. So we have the exponent on x is 2 times the coefficient, which is 10, and this is going to be divided by 4. So 2 times 10, and this is the fourth term. So 2 times 10 divided by 4 is 5. And then the coefficient of the last term is always 1. But to double check that you've done everything correctly, you can go ahead and look at the coefficient of the previous term multiplied by the power of x and divide by the place that it's in. So we have the fifth term, so 1 times 5 divided by 5 is 1. So the coefficient of this next term will be just 1. That should always be the case. So this is our final answer. 6 terms. Notice the number of terms that we have is always 1 more than the power on the binomial. So we should have 5 plus 1 terms. Now let's look at a more complicated example. In this example, our terms are 2x and negative 3y. Why is it negative 3y? Well, if you remember in our very beginning slide, we had a plus b to the nth. We always want that addition. So let's write this as 2x plus negative 3y. And that will be raised to the fourth power. So here, the 2x is our a, and the negative 3y is our b. So those are the things that will be either increasing in power or decreasing in power term by term. So let's not worry about the coefficients to begin with. We'll just worry about raising a to the power and b to the power in each term. So we'll start off with taking the first a to the fourth power. So 2x will be raised to the fourth power. Now b does not arrive on the scene yet in that first term. So let's move to the second term. So I'm going to leave some space for the coefficient. 2x will now go down in power, but now negative 3y, our b, arrives on the scene, and it's on the first power. Plus, leave some space for the coefficient, 2x, now squared, negative 3y squared, plus, lower the power, raise the power, and then we have finally negative 3y to the fourth power. Now we go back and look at the coefficients. So to obtain this coefficient, we need to take the previous exponent on our a, our 2x, and multiply by the coefficient and divide by which term this is. So 4 times the coefficient of 1 divided by 1 is 4. Now we'll just continue the process. 3 times 4, this is the second term, so 3 times 4 divided by 2 is going to be 12 divided by 2, which is 6. 2 times 6 divided by 3, because this is the third term, is going to be 12 divided by 3, which is 4. Now, our last coefficient should always be 1. Let's double check that. Exponent is 1 times 4, and this is the fourth term, so 1 times 4 divided by 4 is 1, which corresponds to what we have here. So, let's go ahead and simplify this expression. So this will equal, well, 2 to the 4th is 16, x to the 4th plus 4 times, now we have 8x cubed times negative 3y plus 6 times 4x squared times 9y squared plus 4 times 2x times negative 27y cubed plus 81y to the 4th. So this will equal 16x to the 4th minus 96 x cubed y plus 216 x squared y squared minus 216 x y cubed plus 81 y to the 4th. Now let me make some notes that might make your life a little bit easier as you double check answers. So first off, notice that this was of the form a minus b. When that happens, your signs alternate. So positive, negative, positive, negative, positive. Another interesting thing that we can go back, and if you're familiar with Pascal's triangle, you might be already aware of this, that there is a symmetry of the coefficients. So you'll notice here we had 1, 4, 6, and then we go back down. So 1, 4, 6, 4, 1. If you look at the previous problem, we had the coefficients 1, 5, 10, 10, 5, 1. So the symmetry will always hold before you simplify. So you'll notice in this example that the symmetry isn't apparent in the final answer. It was back at that initial step.